So my name is Jeff Oishi. I'm an assistant professor of physics at Bates College, and I work on computational methods for solving plasma physics and fluid dynamics problems. In a stellar environment, pretty much everything in the star is plasma, and the exterior of the star all the way through its local neighborhood is generally a plasma. So they're not hard to come by. In the universe, right, they're pretty much everywhere. We should ask the reverse question, why is it that we end up in not a plasma, right? Why are we living in a neutral fluid? And that's because we're in a kind of an unusual part of the universe, not the usual. So in the case of stellar physics, everything is plasma. Everything is ionized everywhere, with some caveats to that, of course. The role of computation in the physical sciences is one that we really need to integrate much sooner and much more thoroughly. The Daedalus project, it's a software project that's now almost 8 years old. We kind of got together for exactly this purpose of trying to build software that was very flexible but very powerful for solving a certain class of equations called partial differential equations, which are sort of the tools we use most frequently to describe the motion of plasmas in this sort of fluid limit, and also to be able to make it easy enough to use that we could change out the model that we were studying without having to rebuild everything from scratch. But our real goal is to make it powerful so we can use it on tens of thousands of cores on the largest supercomputers we can access, but also it runs on laptops, and we're trying to make it as deployable as possible for students to use so they don't have to install it. Really focusing people not so much on the computation, but on the equations and on the mathematics and the physics that they're trying to study. The thing that really gets me most excited is when we can use computation to learn something we didn't know before, and to ultimately make contact with what we did know before and then extend that in some new way and maybe surprising way. I think one way to get excited about plasma physics as a high school student is to go and look on YouTube at movies generated by the Solar Dynamics Observatory, SDO, which is a satellite that just sort of stares at the sun all the time. And it is absolutely remarkable, the level of detail. It gives you a real sense of the range of weird and bizarre motions that occur in this way that has some underlying structure that we can try to understand. Plasmas are fantastically slippery. They move in ridiculous, counterintuitive ways, and trying to get a handle on how those motions work is really challenging and exciting.